Hello to everybody. In this video, we are going to be looking at the solution of June 2021 Pure Mathematics with Mechanics question number 3. So I will display the question and later solve the question. The question reads: a uniform rod AB of mass 2m kg and length 4a meters is smoothly hinged at a point on the vertical wall. It is supported in a horizontal position by a light inextensible string attached to the rod at the point C, where the distance CB is equal to A. The other end of the string is attached to the point D on the vertical wall with D above A, such that the string makes an angle of 60 degrees with the wall. A load of mass m kg is placed at the point B and the system is in equilibrium. A. Show that the tension in the string is 16 on 3 mg, 7 max. B. Find in terms of m and g the vertical and the horizontal components of the reaction force at a hinge, 4 max. And finally C. Determine to 1 decimal place the angle which the reaction force makes with the rod, 2 max. So I would like you to pause the video, try the question on your own, and then we come back to see the solution to the various subparts of the equation. Okay, let's move on to the solution. So I will display the equation so that we try to come out with our diagram together after reading the equation. So firstly, we have a uniform rod which is AB. It is attached to a wall. It is smoothly hinged at a point on a vertical wall. So definitely if it is AB, then it is hinged at the point A to the vertical wall. Now it is supported in a horizontal position by a light inextensible string that is attached to the rod at the point C, where the distance from B to C is A meters. Now the other end of the string is attached to the point D on the vertical wall. That's the point D which has been indicated, where D is above A. So perfectly we have seen that this is how the diagram is supposed to look like. Now we have something else. The string makes an angle of 60 degrees with the wall, so it means that it's going to make an angle of 30 degrees with the rod. Now a load of mass m kilograms, so before indicating the load, we know that is a string, so there is going to be tension. Now the tension is going to be resolved into two components: the vertical component, which is Ty, and the horizontal component, which is Tx. Now the weight of the rod always acts at the center, so we have 2 mg since the mass of the rod is 2m. Now at the point B, a mass of m kg was placed, so the weight of that mass is mg. Now let's try to indicate the various distances, but remember we have a reaction force at the hinge A, so we can resolve into two components: the vertical component representing small a and the horizontal component representing small b. Next, we can try to indicate the distances. Remember, the weight acts at the center of the rod. The rod is 4a, means that the distance from one end to the center will be 2a. Now since the distance from C to B is a, it definitely means that the distance from the center of the rod to the point C is also going to give us a. Now let's try to look for the components of the tension vertically and horizontally. Alright, so that's it. So we have the angle 30 degrees that the tension, or the string, makes with the rod, makes an angle of 30 degrees. Okay, now we can use a suitable trigonometry ratio to find the various reactions, the vertical and the horizontal component. So cosine of 30 degrees is equal to, we know cosine of an angle is the adjacent of that angle on the hypotenuse. So we have the adjacent, which is T of x, divided by the hypotenuse, which is T. So from there we can find T of x as T cosine of 30 degrees. Now let's see how we can find t of y, which is a vertical component. We can now use the sine of 30 degrees. So the sine of 30 degrees is equal to t of y, which is the opposite t of y. This is equivalent to this, the opposite divided by the hypotenuse, which is t. So our t of y is simply t, the sine of 30 degrees. Okay, so that's it indicated in our diagram. Now let's proceed to solving the first question. Question A. Show that the tension in the string is 13 on 3 mg and it is allocated for 7 marks. Okay, so this is our diagram that's been given. Now we're being told that this system is in equilibrium. Now what does it mean for the system to be in equilibrium? First point, the clockwise and the anti-clockwise moment at a point are always the same. Second point, the algebraic sum of the forces is null. So we are going to apply these two conditions, but for the first case we are just going to apply the first condition. So let's see how it goes. So taking moments about the hinge, which is A, about the point A. Now we first of all need to choose our reference frame. So we take that the upward direction for the forces. All forces pointing in the upward direction are positive, and to the right are also positive. Now for moments, if we are considering moments in this direction, that is clockwise moments, we consider this direction to be positive. Therefore the reverse, which is anti-clockwise, is going to be negative. So if we take moments about the point A, that is the hinge, remember the moment of a force is simply the force times its perpendicular distance from that point. So the moment of a force about a point is the force times its perpendicular distance from that point. So taking moments about the point A, we have two moments. We have the two types, which is the clockwise moments and the anti-clockwise moments. So we begin with the clockwise moments, and remember we are summing these clockwise moments because we have many forces involved. So clockwise moment, it means that there are forces that are making the rod or the system to go in this direction. So in this direction, like it is indicated here. So the first force is going to be the force A, which is acting at the point A. So the force small a acting at the point at the hinge where we are taking our moment. So its perpendicular distance will be 0. Definitely there is no distance because it is acting at that point. So we have A times 0. Now next we have 2 mg, which is this guy, because it causes this guy to go like this. So you have 2 mg. Now its perpendicular distance from this point is simply this horizontal distance, because this distance makes an angle of 90 degrees with the force, that is the weight. So we have 2 mg times its perpendicular distance from the hinge, and the perpendicular distance is 2a. Now we proceed with mg times its own perpendicular distance. Now this is mg. It is acting at one end of the rod, and we are taking the moment of this force about this end of the rod. So its perpendicular distance is simply the length of the rod, or definitely a plus 2a, which is 4a as indicated. So plus, now we have c cosine of 30 degrees, because it is going to come like this. So coming this way is going to reverse, so it is clockwise moment. So we see c cosine of 30 degrees. What is its perpendicular distance from this point? Is simply 0, because it is acting along. If I draw a line along this point, I see that this guy is acting along, meaning it is parallel, so it has no perpendicular distance, so the distance is 0. So doing all of this, we are going to yield 8 mg, because this will give us 0. Now this will give us 4 mg, this will give us 4 mg, adding we have 8 mg. Definitely this is going to give us 0. Now what about the sum of the anti-clockwise moments? Remember, this is our reference frame, this. So if we are taking this as our clockwise moments, it means that the reverse, that is this other way is going to be the anti-clockwise moment. So it's going to take all the moments in that direction are going to be negative. So we have you have this guy t sine 30 degrees. You see it is causing the beam to like go in this direction. All right, so we have first is negative b. Remember, it is anti-clockwise moment and b is going towards this direction, meaning b is positive. But since it is anti-clockwise moment, with the directional, this sign becomes negative. So we have negative b times its perpendicular distance from this point, and the perpendicular distance is 0. We can simply see that there is no distance because b is acting on at the point. Okay, now the next is going to be t sine 30, but it is anti-clockwise, meaning it is negative. Remember that the force is positive because it is pointing upwards, as our reference frame says. So just t sine 30 degrees, which is the force, is positive. But since it is causing an anti-clockwise moment, we now indicate the negative due to our reference frame. Anti-clockwise moments are going to take the negative sign. So we have negative t sine of 30 degrees. Now its perpendicular distance is simply this distance, the distance from C right up to A, which is 2A plus A. So we have 3A. So doing that, we have this is going to give us 0. This will give us negative 3AT sine of 30 degrees. Now we know what sine of 30 degrees is 1/2. So we have all of this to be negative 3T on 2 MGA. Now at equilibrium, we have the first condition, which says that the clockwise moment and the anti-clockwise moment at a point are the same. It therefore means mathematically that the sum of moments, the algebraic sum of moments about a point, is equal to 0. Now our point is A, so the algebraic, meaning that we should include the sign of that moment. So the algebraic sum of the moments at the point A will be equal to 0, meaning the sum of the clockwise moments and the anti-clockwise moments will be null for sure. So with that said, we have that 8 MGA, which is the sum of the clockwise moment, plus negative 3T on 2 MGA, which is sorry, there is no I think there is a little error here, so make sure you correct it. In this place we don't have M, so as you can see here, so it's definitely a mistake when I was typing the solution. So here we don't have M. Alright, so we have negative 3 on 2A, that's this guy plus this guy. Remember, it's the algebraic sum, that's why I'm including the negative sign here, be equal to 0. This therefore means that 8mg is equal to 3t on 2, because the a's are going to cancel, because a is different from 0, it is a length and the length cannot be 0. Okay, so from there we can conclude that our t, which is the tension, is equal to 16 on 3 mg, which is what we're required to prove. Alright, second part, find in terms of M and G the vertical and the horizontal components of the reaction force at the hinge. 4 marks. So the vertical and the horizontal components of the reaction force at the hinge, meaning that we are finding what? The vertical and the horizontal component of the reaction force at the hinge A. So we are finding the force small a and the force small b. Simply, we use the second condition for a system to be in equilibrium. The algebraic sum of forces is 0, meaning we sum the forces considering their directions. Now we are just involved with, so we first of all begin with the vertical, which is in the y direction. So sum of forces, the algebraic sum of forces in the y direction equal to 0 means that we now pick all the forces in the y direction. All the forces going up are positive, therefore going down will be negative. Going to the left, that's with the x direction, we are going to come to that. Alright, so going up we have A, we have next, which is going up t sine 30. That's all. Now going down we have 2mg and mg. So it means that our A is simply equal to 3mg minus t sine 30, but t is 16 mg on 3 as we have seen here, and sine of 30 is half. So simplifying, we have A to be equal to mg on 3. Now let's take the horizontal direction. We have the sum of forces in the x direction equal to 0. Now in the x direction we have only two forces. We have the force B, which is the horizontal component of the reaction force at the hinge, and we have T, the cosine of 30, which is the horizontal component of the tension in the string. Alright, so by so doing, it means our B, which is positive, is simply equal to what? Our T cosine of 30 degrees. Therefore meaning that our B is equal to 8 root 3 on 3 mg. Remember, our T is 16 on 3 mg, and the cosine of 30 is root 3 on 3. So simplifying, we have this. So with that said, we have found the vertical and the horizontal components of the reaction force at the hinge, and the equation was allocated for 4 marks. Okay, let's move on to the last part of the equation, which says determine to 1 decimal place the angle which the reaction force makes with the rod, which is 2 marks. So we just still consider this our diagram. Now the angle that the reaction force makes with the rod, we try to indicate it. Now we had the reaction, the vertical and the horizontal component of our reaction force. Those are their numerical values in terms of mg. Now we have this, we try to indicate what is actually happening. So vertically, the vertical component is A, the horizontal component is B. That's the reaction force, we can call it F. Now we are finding the angle that the reaction force makes with the rod, meaning that we are finding the angle theta. So this force going down is simply the same as A. So that is the rod AB. So theta is the angle that the reaction force makes with the rod. So we can use the best trigonometry ratio to find the angle theta. Since we have the adjacent and we have the opposite to this angle, we can therefore use the tangent of theta. So the tangent of theta is simply equal to what? The opposite, which is A, divided by the adjacent. So it means the tangent of theta is, our A is mg on 3 and our B is 8 root 3 on 3 mg. So simplifying, we get that the mg's are going to cancel. The 1/3 here is going to cancel the 1/3 here. So we are simply left with the tangent of theta is equal to 1 on root 3. But remember, we are finding the angle, not the tangent of the angle. Meaning that our theta is equal to tan inverse of 1 over 8 root 3. So that's it. So your assignment is actually to compute this value and put your answer to 1 decimal place. Always read the instruction. Determine to 1 decimal place, meaning when you compute this value, your final answer should be in 1 decimal place. So that was that about the video. I hope you loved the video. If definitely you love the video, please subscribe to the channel if you have not subscribed yet. Also turn on your post notifications so that whenever a video is being posted, you'll be one of the first persons to view the video. Endeavor to like the video and share to your friends who are taking the discipline pure mathematics with mechanics in the advanced level. Thank you so much for your time, and see you later.